Okay, in this video clip, we're going to take a look at the Tidyverse suite, and we're going to use a data set which contains 53,940 rows and 10 variables related to diamonds. Now, importantly, we have here the price of diamonds that range from 326 to 18,823. I think these values are dollar values, US dollar values for 2008, so they're not current, but perhaps what the data set reveals and can be interesting is the relativities, right? So not all diamonds are the same, and we can look at what sometimes is referred to here as the 4 C's: the carat, the cut, the color, the clarity. And the carat denotes the weight of the diamond, and I think 1 carat is approximately 200 milligrams. And then we have the cut, which in this instance is categorized into fair, good, very good, premium, and ideal. And then we have the color of the diamond, which goes from D, best, to J, worst. And D would be the clearest, the clearest, and J would be slightly more tainted with yellow. And here going to J is referred to as worst, but there are other categories of diamond in terms of color, and there are some diamonds that, despite being very yellow, command high valuations. So we can have a look at those in a moment, but in a very interesting, but in a very targeted fashion here, we're just going to look at the range from D to J for diamond color. Again, these are industry values that we're going to work with. The clarity is a measurement of how clear the diamond is, right? So, and then we have X, Y, and Z. That looks a bit like gobbledygook, but we have some explanation, which I'll show in a moment. And then we have depth, total depth percentage, and the table width, and a range of values. Now, I found that this link here, right, is shift and then which comes from the Duke University. It's looks like from their statistics department, and they have some interesting schema here that explain a little bit the value of the diamonds. Now, again, it relates back to the Tidyverse data set, and this looks like a range of nice exercises that you could do. But I was looking for proprietorship and authorship here, but I can't seem to find it. Nevertheless, let's for a moment take a look at some of what X, Y, and Z refers to. Maybe before we do that, it's noted here that what influences the prices of the diamonds, and again, the diamonds are for, again, it's the Tidyverse, it's the same data set that we're referring to here. There are 2008 prices, dollar prices, and then the 4 C's, carat, cut, color, clarity, seem to be what feature heavily in terms of how to value diamonds. And then we have some physical measurements: depth, table, price, X, Y, and Z. But price also is very interesting, because what it provides is a kind of a dimension, social dimension. How do we perceive what is the valuable diamond relative, and what properties are correlated with these higher valuations, right? So how, in terms of carat, cut, color, clarity, how do they impinge then on the price? And the visualization that's available in Tidyverse can be very useful in that regard. So part of our storytelling here is having a nice set of pictures, and we're going to make use of Tidyverse to explain a little bit what's going on. Now, note that X here denotes the furthest points in terms of the width of the diamond. So X is the widest points on the diamond, and then the table width is at the crown of the diamond. Here we seem to have with the cut, the table width is the width at the top of the diamond, and then the depth is going from the widest point down, but then Z, which is the Z depth, but then Z is going from the crown to the base. And when we come over here and refer to the depth of the diamond, it's equal to Z depth divided by Z, it's equal to Z depth divided by Z multiplied by 100, and the table is equal to table width divided by X, seems to be the widest points on the diamond, multiplied by 100. Okay, so that's depth and table. And then in terms of carat, carat is a unit of mass equal to 200 milligrams. And we use this for measuring gemstones and pearls. And the cut is the grade, an objective measure of a diamond's light performance. What is generally we think of sparkle. So there's different cuts in the diamond, and then we have different color as well. So in our schema, just on the Tidyverse, the 53,940 diamonds we have, they range just from D to J, and this was noted as being the best, and this is the worst. Now there are other diamond categorizations: faint yellow, very light yellow, and some can have some other categories have higher valuations, but it's noted with this data set D is the best and J was the worst, right? That was indicated in the Tidyverse. But other and D denotes the lightest coloring, so hardly any coloring, and J where you have some taint of yellow, near colorless, right? And then clarity here, the grading of the diamonds, and again this is related to the sparkle. Now we can go back and take, there is another reference I have in RStudio. We might just take a look at that also. Diamond information. Let's just copy this. Can I control and just see? Maybe copy. And there's some more useful information here. I think it's actually cropped up here. And we have search diamonds, and we have some information as well. So this is a much bigger data set, 261,198 GIA certified loose diamonds. Of course, it's current because it's 2021. And this is the evolution. Now, this is not the price of a given diamond. It's like an index. So it's not a dollar value we have here, as far as I'm aware. It's an index. And the main focus of this site is price trends by online diamond merchants. Online jewelers base their prices on a well-trusted source in the industry. And then it tells us a little bit about the cut. The beauty of the diamond resides not only in favorable body color, but more importantly in its optical properties. Color: most commercially available diamonds are classified by color, more appropriately lack of color. So if the diamond is clearer, that's seen as being better. Clarity of a diamond is determined by the number, location, and type of inclusions it contains. And the carat weight, the weight of the diamond and all other gemstones, is measured in carats. We've table width. Table width is the quote as the percentage of the average width of the diamond's girdle. And total depth. The total depth percentage is greatly responsible for the amount of brilliance that a diamond will display, and so on. So just symmetry, fluorescence, and so on. But we don't have reference to those in our data set. Also, just if you're interested in looking at the price index here, we have some diamonds, current values, and we can see the valuation. Here's one commands a very high value, 73,000. It's 0.81 carat, so it's very big. This 2 carat one here is 15,000 loose diamond, and you can see the VVS1, and this labeling is incorporated into our Tidyverse data set. So we don't have the data set we have will range in price from the mid hundreds up to, I think, $15,000, and is 2008 prices. This, if you follow through to diamondsse.info, that will provide you with more current information about diamonds. Okay, let's get back then to our data set. Let's do some simple visualizations. We won't get the values we have here, not contemporary, but what we can, or current, but what we can see is the relativities and how one type of diamond would compare to another. I should mention here as well, there's another data set, another interesting portal that I found, and there's a name there, and I'll mention that name. It's Dr. Avi Wohl, Senior Lecturer of Finance. I think he's actually a professor at the Tel Aviv University. The diamond index is updated every hour. And this is one that goes back 5 years. And then we've current average asking price. So we have different driver click to view more detail. Okay, so again, we've G colors. So those colors will emulate, and then you can see the clarity. So the same labeling as we'll use, and cut. So cut, carat, color, clarity, right? Okay, so that's an interesting data set. You might take a look at also, and homepage. Let's just see what's there. Diamond index derived in real time from actual global industry prices. The IDEX online diamond index objectively reflects price trends as they happen. Okay, so it looks like a very nice data project that they're pulling in data and reporting the price of diamond. Search and view real-time average asking prices for all available categories for polished diamonds derived from inventories estimated more than $4 billion. And then we have the diamond price report and an analysis of international wholesale. So this is wholesale prices as opposed to retail. Asking prices for better quality diamonds published weekly. This reliable, transparent, unbiased pricing tool is based on price changes as seen on IDEX's trading platform. Okay, so it looks like a very nice website, and there's a lot more to explore there. Okay, without laboring too much further, okay, let's use the Tidyverse package that's here available in R. Now we don't have to install. It's already installed. So if I look at packages and put in here the search engine Tidyverse, what I'll find is I've already got this installed on my machine. I won't install again, but if I did want to install, all I would have to do is come down here to put in Tidyverse V. It's prompting, then click on install, and it would install. Or I can run that manually here in RStudio, install package Tidyverse. To make it available in this environment, I'll say library Tidyverse, and that has the effect of bringing into our project here ggplot2, the plier, forecast stringer, tidier, and so on, all the packages available in Tidyverse. And we can take a look at what's in there, right? If you want, description of file. Okay, and there's enough there to work through. Now, we want to take a look at our diamonds. We can use the str function, and that provides us then with the price of the diamonds, right? And then carat, cut, color, clarity that we mentioned a moment ago, and then we have the XYZ. Okay, and we can go data diamonds. It comes up here in our global environment, and then let's have a look at some descriptive statistics. So the carat ranges from a minimum of 0.2 all the way up to 5. So that would be our biggest diamond in this data set of 53,190. Sorry, 53,940 diamonds that we have in our data set, and we have 10 labels describing the properties of the diamonds. We have a breakdown of the cut. There's 1,610 that are judged to be fair, 4,906 that are judged to be good, very good, premium, ideal, 21,000. So most are ideal, it would appear. And then the color goes from D to J, and the bulk are here in G, would appear. The clarity, SI1 would appear, and VVS1, VVS2, VS1, and the bulk are here. Now, in a moment, we'll be able to visualize which ones are the most valuable, right? And what type of effects these different properties have on the price. And that would give us a sense of how to judge the value of the diamond and what qualities are held in high esteem. Okay, so first and foremost then, a simple thing to do is just look at the cut of the diamond. Now we had the cut here. If we run the ggplot2 function here, we say, look, our data set is diamonds. If we double click here, we can see in the eViewers, in the RStudio viewer, and we can see what's in our data set. So 53,940 rows, so 53,940 diamonds. And we looking at the cut here, right? We can see, yeah, fair 1,610, good is 4,906, very good, ideal, there's 21,551. Now, what's going on? It's a bar chart, and we're just looking at, we're using on the x-axis the cut, and then we're counting the number in each category, right? Now, you could also set up a tribble. Because of the Tidyverse suite, we can set up a tribble, and we could attribute these values to each of the categories set out here and run that, and then say, look, instead of taking diamonds, let's take the demo, and then employ again the ggplot syntax, and we can pull out. Now this time it's arranged on alphabetical, so F, G, I, P, and V, right? But it's basically the same graph as we had before, except now we have an alphabetical order based on the tribble. Okay, we could use a stat summarize. Again, this is coming from the Tidyverse, so it's coming from the HTMI, from the R for Data Science. So this textbook, which we are told will be free and always free, so R for Data Science. And again, if I put in the diamonds, in the search, if we look at 3.7, right, that's the first reference then to diamonds. And I'm basically following along the code here. You can see I've taken from R for Data Science, and I've appended it, I've copied and pasted it into our RStudio. So the snippets of code that I'm using here, I'm going to take from R for Data Science, and I'm putting into the RStudio. So you might want, so the current one, the graph I'm doing here, I've copied this snippet of code, and the stats summary, you might want to draw greater attention to the statistical transformation in your code. For example, you might want to use stats summary, which summarizes the Y values for each unique X value to draw attention to the summary that you're computing. So we're going to set up the minimum, the maximum, and the median for the fair, the good, the very good, premium, and ideal cuts, and we're getting the depth, right? So in this instance, we're going to get the depth. Okay, let's take a look at that then in RStudio, and let's run that snippet of code. And this is for each of the depths, right? The fair, good, a very good, premium, ideal. Now we could change this, I'm sure, to price. Let's see what the effect is. Price, and run again. Okay, and what we observe, the median looks quite close now, 5,000, just under the 5,000 for each, and then we have the same range. So we have the cut in terms of the valuation. It's not clear what's going on in terms of price here and how the cut impinges on the value, the price. We probably need another visualization, but what we're getting here is median value. No, the median value is being reported, and then the minimum and the maximum, right, values. Okay, now the next snippet of code I've taken from Professor Andrew. We could take a look at her portal, but I might just run this first of all, just to take a look at a scatter plot. So a jump point is a scatter plot, and there's latency here, even though I have a gaming machine. It actually took a little while for this to come out. So we have the carat and then the price. And it would appear the higher the carat value, so the bigger the diamond, the more valuable it is, right? That would seem to be quite clear. And then we could say, look, let's run the same. So it's basically just a scatter graph with the 53,940 diamonds. And you might want to look here at the color. We mentioned color a moment ago. The diamond goes from D to J, D being the best and J the worst, right? So the clearer the diamond is, the more valuable it is. And we can verify that those diamonds, what is their value? But we break up, if you like, the scatter graph so that it is disaggregated for the different color. And it's a bit unfortunate color is equal to color here, but all that's going on is we're looking at going from D to J and creating, making it explicit which diamonds are D, which diamonds are E, F, and J, right? So we get this classification here on the side. And you can see here the darker this D, so I shouldn't say darker because actually D denotes clearer diamonds, but D here, they're more, now there's variations, right? But the bulk of those we'll find here. So it would appear that the clearer diamonds command a higher valuation. And then J, which are regarded as being the worst, you can see you need much bigger carat size to get the higher valuations going above 15,000. Maybe this is something like 17,000, right? So at a smaller carat size with clearer diamonds, right, we have higher valuation. Again, to maybe understand a little bit what's going on here, remember D to J. So D being colorless and J being a little taint, right? That's what we have here. Okay, so we could try and do the same again, but this time we're going to look at, we had cut, color, and clarity. Why don't we put in cut, C-U-T, and see is anything revealed by that, right? So we're going to get a classic, I'll just run, but we're going to get a classification here on the side relating to cut, and I need to run that, and it's going to take a little time because again we have 53,940 separate diamonds, and producing a graph then has some latency. Now ideal, so these are split up into fair, good, very good, ideal, and it's more of a mixed bag, but there is a preponderance of yellow denoting ideal here, this side, and there's more a preponderance of fair on this side. So it would appear that diamonds that have an ideal cut, all else being equal, seem to command higher valuations, and those diamonds categorized as having a fair cut have lower valuations or require higher carat size to reach the same valuation. Okay, so it's a mixed bag. It's not completely conclusive, but there's a tendency that the ideal is worth more and the fair is worth less. Okay, that's what we might say there. And then the other category then, so we had we're looking at the color, and we are looking now at cut. What about clarity? Right, so let's run this again for clarity. And it's not immediate, right? It takes a little time. So, and did we run? Yeah, so even within this environment, using a gaming machine with 16 gigabyte of RAM with an i7 core processor, it takes a little bit of time to run this query, this command. And what we observe is IF is worth more. And I think it's more pronounced here, right? And we're also getting something a bit funny. We're getting these gaps. If you notice, preponderance just after. So if you notice here, when we get the carat one, there's exactly one, there's an overrepresentation. Then at 2, a slight more an overrepresentation. At 3, at 2, more preponderance of values appearing. Now, what possibly is happening here is when the diamonds are being certified, if they're close to exactly 1, they're pushed up to 1 and certified perhaps as 1. I can see how in an industry that requires certification, if you're close to 2 or 1.5, there's kind of a push to get to that, to round up to those figures. So I think that's what we're observing here. And there's probably an over-representation just above or at the unit point, right? So again, you can see a little bit maybe what's happening in terms of how the diamonds are registered and recorded. But also it must be noted IF here is worth more. So clarity with IF is worth more than clarity with I1. You can see here with the clarity of I1, right? We're getting less, it's less clear. So again, they're less valuable. You need a bigger carat size to command the same valuations of diamond that is IF. And again, I think that's the luminosity, how the light passes through the diamond. And the more the light is refracted, of course, the more eye-catching and the more valuable the diamond is, right? Okay, so so using the syntax here, the verbs in ggplot, we can actually pull out and educate ourselves a little bit about the relative values of diamonds. Now, of course, these values, I'm not 100% sure if they're wholesale or retail. I would say wholesale. And again, it's 2008 prices. And of course, the prices are changing all the time, right? So this is not a guide really in terms of the value of diamonds. It's more revealing in terms of the properties of diamonds and how then one diamond would compare to another, and using the Tidyverse suite to reveal that. Okay, so color a bar chart using the color aesthetic, or more usefully fill. So basically here we're going to set up a bar chart. So Jum bar is going to provide for us a simpler type graph, and basically the proportions of what we saw before: fair, good, very good, premium. Okay, it's we're getting the color is equal to the cut, so we're getting a little bit of color here, and if we change it from color to fill, then the whole bar is filled in with color. And again, it's colorful and interesting, and if you're writing a report, it would be easy to export that, so we could save it as an image or we could copy it to a clipboard and maybe change it around a little bit. So we could maybe give it a little bit more height, for instance, copy plot, and then we could go out to a Word document. So let's see, and file, new, and then if we're to paste in, Control V, and you can see we have a nice graph, right? So that's one of the main strengths with RStudio, that it produces very nice graphs. You can put in some labeling also, and it's very compatible with Word. Okay, now the explanation we already addressed with taking the information from Duke, but the code that we have here is coming directly from chapter 3, or for data science, the visualizations. And you can see here what we've done is we've taken each of those categories we had before, and we said, okay, now break them down for the preponderance of clarity. So I1 there and IF here. So ideal would appear there's more of this with the ideal, and less so in fair. We see less IF, right? And if we go back, toggle through our graphs, takes a second, right? We could see the relationship. In fact, that's going to take, okay. So we can see here different cut and clarity. So IF was worth the most, right? And we can see with the ideal cut, there's more IF with the ideal cut, would appear, relatively speaking. Okay, so that's interesting. And again, something similar, but just a slightly different syntax, and it's very eye-catching and very useful for writing reports. So some of the features here are really nice in terms of graphing. And we can do a bar chart. Now, this is an interesting one because it gives us if you like, the count, but then it breaks apart. So we're counting the cut, right? So we're doing a count, but then we break each of them: ideal, premium, very good, good, fair. We break them apart for clarity, the separate categories of clarity. And again, we can see a greater preponderance here of IF, which is the most valuable clarity. It's a property that we put more value on. And we associate that with ideal, and that's not so evident over here with the fair cut. Okay, now a very simple bar chart. Okay, we did that before, but it's for cut, and I think we're down here to the last. So in this instance, we're going to do ggplot again. It's going to be bar chart, and then it's we're going to flip it. Right, so we've basically our bar chart again, but it's flipped, and then we're going to do a coordinate polar. So basically, it gives us another optic, and whether this one is clearer than this one, I'm not sure, but they both contain the same information based on what we have here. But I suppose to spice it up a little bit, this is interesting. And you see this quite a bit on the Kaggle, particularly for the FIFA players, where you're looking at particular attributes. And sometimes it's a nice way of summarizing, a player's key attributes. Okay, so that's there's more in the R for data science. Tidyverse based on the diamonds. You can check that out if you go into the portal there, and just put in diamonds, and you see all the code that relates to that. I think I've put in a lot. I didn't put in the modeling. Let's see, do I have this one? No, I didn't put in. There is a reference here to diamonds, so you can go through if you're interested in this. It's worth working through. There is some modeling here, model building in chapter 24, box plots, and so on. and they are definitely interesting and worth going through. So we have a model here built, a linear regression model, where we regress the carat on it, probably it's the log of carat on the log of price, and we could get some output there. In fact, we could just copy. Now we've diamonds 2 and L price. I think L price must have been created before, right? Probably log values. Okay. Anyway, that's possible, and maybe I'll leave that to individuals to do themselves. But there is quite an amount of interesting detail here, and the Tidyverse suite, its visualization properties and so on are definitely state of the art, and I encourage people to make use of it. It's a free resource, and in a following more videos that I'm going to do here, I'm going to set this up in Google Colab, and I'm also going to try and investigate a little bit the ggplot graphing capability that's available in Python, right? So given the success of ggplot and the extent to which people find it useful for their graphing, given that it's so popular, there are various ggplot packages now available, or libraries now available in Python, and I'll introduce those in some video clips that I will leave a link to below the video. Okay, that's it.